I'm going to try and repair this thing. The question is, what actually is it? So the first clue here is it says Tektronix along here. Also has it across the casing here, which you can't currently see because the lighting's on it. But anyway, we'll open it up. You don't see many of these things around. They are around, but there's not many of them. This was generously donated to me by Steve, Capo Steve as he goes by on YouTube. He's over in the UK, my wife was over there, and they managed to arrange to meet up, and he handed this over to her, and so she's brought it back. So it's a Tektronix 851 digital tester. Now the thing with this is that it kind of works. It's got some issues. I've had a quick play around with it already, just to sort of evaluate it, and a couple of the ranges and the resistance play up a little bit and things like that. I think it mostly works. It wasn't anything too obvious apart from the resistance ranges. I haven't tried much else as far as accuracy. It seems to be counting up and totalised, stuff like that, and its periods and widths seem about right for what it seems to be putting out. I don't know if it's on frequency. It's got a 5 kHz, I think it's 5 kHz output on it, and that's used for various functions like this cal out over here. So I'm not sure if it's even in frequency. I don't know. I haven't measured any of that stuff. That's all calibratable, I believe. It's got some weird connectors on here for these probes. Really unusual things. They're this is the connector here. I'll show you. That is the connector. Very, very odd. Very odd. Alright, so to plug this in, it took a while to figure this out. In fact, I never did figure it out, someone told me. If I'd read the manual, maybe I'd know. So you've got this connector on the side here. So this ring, you have to push it down in order to push the connector in. It's still quite a tight fit, even with that. Alright, so you can't pull it out accidentally. So you get it in and out, you have to push that collar down first, and then you can kind of yank it out. So, interesting connectors. I've never seen anything like that before. Maybe they're used in some other stuff too, I really don't know. But, very unusual. Kind of threw me for a little while. Alright, so this front piece here actually comes off. So you can take that off out the way. Designed to come off like that. So you can set up on your bench just like this, or you can have it the other way with like the probes and stuff in the container. It feels a bit like there may be something across here, maybe it's missing. I'm not sure. I'm guessing there could be some kind of trim which is missing, but I don't really care too much about that. And that's what it really looks like. Big ass heatsink. Now when I did my initial inspection, I don't know if you can see it on camera or not in there. Get closer, maybe you better see. There's some. It was quite wet in there. You can actually see it's still a little bit there. I think some more might have even come out actually. It's like wet in there, and it's actually a little bit green and corroded. So I'd actually give it a bit of a clean up in there before. So it's had something going on. I'm guessing there's a bad capacitor somewhere or something like that. Maybe that's a filter unit. I think there's probably a filter assembly on the back of it. You know, some of these IAC filter units. I think it's probably one of those, and I think it's probably failed. That's what I'm thinking. It won't be the first time. They're quite prone to it. When they get old, capacitor fails inside them. So anyway, we'll get this thing opened up and have a look. Now some screws on the bottom which are actually missing because the mounts are broken off. The plastic is broken. I'll show you those. It's down here. Bit of a shame, but that sort of stuff happens, doesn't it? So you haven't got many screws to take out. I might have to see if I can find a way of repairing this. Maybe build it back up again with some aldite or something, put like a screw insert in there. I've got some metal inserts, brass inserts, which are threaded, so you can actually, they're meant for being pushed into bits of plastic anyway to make threaded inserts. Well, they are threaded inserts. So I might even look at trying to make something which works with those, so I can re-secure those bottom bits of casing. If it matters, I mean I might be fine with that, but I'd like to try and restore it if I can. Okay, so it screws out, hopefully. Does it open? It does. So I'm just looking at this power button assembly, this power switch on the front here. Because this has got a lever mechanism on it, which rests against the switch here. Now this switch is actually working, but the switch on the front wouldn't actually stay latched in position. So I wonder if maybe it is a case of it not being aligned. Curious. Little weird little things like that. It's got some weird assembly designs on it. Anyway, obviously this is the main power supply in here. Pretty big caps. I'm just looking for any kinds of damage or any obvious signs of bad caps. And it's got quite an interesting like modular design. The boards, they have edge connectors, they plug into each other. So can I unplug this stuff and not mess it up? Let's see. So I've got a connector up here, got two multi-way connectors. Need to make sure I make a note which around these things go. I'm going to unplug stuff. Let me just have a quick look first. They might be marked. They don't appear to be. Right, see if I can mark these things. Just mark that. Right. It has a ground tab connected across here. We've got this thing here. Alright, so this leaves this earth one to get off. Sure, it doesn't have a connector on there. Got to desolder that. We'll do that and get it apart. It's quite a large mass to try and desolder. There we go. So that's that off. So now I've got the power supply section disconnected from the main system. Actually, I'll show you the inside properly. There we go. That's what the inside looks like. Very interesting setup. So it's got these edge connectors on there, all kind of plugs in together. So it's an interesting design. A whole bunch of little edge daughter boards and there. In that section there. The threaded mount is also breaking. So most of the screws that hold this thing together are breaking, which is a shame. Well, I've had a quick look at those caps and I can't see anything obviously wrong with any of them. They all seem to be basically alright. Now, it looks like it's got some test points along the front here. So hook probes here. And I believe I can actually power this thing up without being connected to the main unit. As long as I don't short anything out. Because this is just a standalone power supply basically. And being linear, I think it's mostly linear. I mean, there are some inductors, but it might just be for filtering. Pretty sure it's linear supply. And I think there's, oh, no, actually I might have had some switching. So maybe I have to be a little bit careful about what I'm measuring. But a bit of dust in here. I'm trying to read what these say. I think it says 14, 5, ground. That's an earth. So think it says -14 there. Yeah. But it has more supplies than that on it. I guess those are the main ones, because I think it does have some adjustments in there too. Yeah, there we go, there's adjustment just there for one of the rails. Let's look at the bottom of the board here. Here we go. It's also got silk screen markings on the bottom, which is nice. So 5V reference, ground, -14V. Does it mention any other test points? Doesn't seem to. Those are the ones it actually mentions. So they're probably the ones I have to check for accuracy. But as it has multiple connections going to the boards, I'm guessing it actually has a lot more than just the ones it's showing. Well, at least I can get to all the caps. I can get to both sides. I think I can get to all of them at least. So I'll do checking on those to make sure they look okay. Oh, there's the voltage switch just there, which I didn't notice before. Sitting underneath, so you can get to that from outside. I didn't actually see it before. Didn't even look for it. It came from the UK, so it would have been right anyway, because they're the same voltage as here. The fact the switch works properly, that's a bit of a relief, say, because on the main panel there, the on-off button wasn't actually behaving the same way. It always seemed to be on. It wouldn't actually latch off. So that is interesting, the way there's a bit of a discrepancy between the way the switch is actually working and the way the front panel switch is actually working. A bit weird. Oh yeah, there you go, there's another adjustment. There's two adjustments. I thought there's two. One there, one there. I thought there were. Okay. Should we power this thing up and see what happens? Do some testing on it. It's got like an interesting arrangement here for all the transistors along the back. It's got these like leaf fingers that clamp onto each part. Don't see any thermal compound. Guess they figured it didn't need it. Maybe we should do some capacitance tests before powered up. They should be discharged anyway. And we'll just do some basic checks on those. See if anything looks about right. Although in circuit you can't be 100% sure anyway. That will give us an idea. First thing I want to do is make sure they're actually discharged. They should be. Yeah, they're all dead. That's fine. So let's get my LCR meter out and have a look. ESR looks good, 5.45 millifarad. So this is rated at 4,700 microfarad. Is that 10%? No, it's a bit more than that. Maybe it's an issue. Let's look at dissipation. 0.225. Little suspicious. It's only 16 volt, but it's axial. Being axial is a bit of a pain because I don't keep a lot of those. I don't have that value. Look at my drawers, I don't have that value in axial. Check the next one. 2,400 microfarad, 30 volt. We're getting 2.6. Dissipation looks alright though. ESR looks alright too. Next one. So I was suspicious about this one a little bit. That dissipation was a little bit high. So this is 750 microfarad. So that's what it looks like. Try and set the voltage. I think it's 40 volt. So you're getting 900 there. Again, it's also increased. So all these values are coming up as being higher. And usually when you get an increase in capacitance, it usually means they're starting to dry out. They're starting to fail. Usually. That's 0.095, that's not too bad. It's probably okay. But I'm suspicious anyway. Minis are old, so it's not too surprising. Let's try and get on here. Yeah, popping off. Got no idea what this one is yet. I'm guessing it's going to be 1000 microfarad based on that value. $1150. Dissipation looks alright. ESR looks alright. This one's looking very similar. So there's nothing obvious so far, at least. Apart from this very first one, which is quite bad for dissipation. But they're all reading a little bit high. Got these other ones to check it. I can't see what those values are. It says made in USA. I can see that bit. Sprague. Don't know what values are, but my guess would be 1000 microfarad. So we've got these other ones here. So that's 6 of those. 3 of those other metal ones. Let's try and look at those then. Now I've lost them. Where are they? Here. Oh. Yeah, that's right. .5 ohms might be okay. 28 microfarad. 1.6 ohms, 28 microfarad. Okay, so that first one probably is going. Let's look at this one here. 0.5 ohms to 30 microfarad. That was looking more likely to be okay. The very first one seemed a bit dodgy. Where's the other ones? Decent connection. 0.2 ohms, 536, that seems okay. And there's some more down here somewhere. .3 ohms, 28. Might be a little bit high. And the last one is where? Yeah. 0.5 ohms, 238. Looks okay. And they've got these big metal ones to do, which I think are there. Yep, that's those ones there. Don't slip off. 0.2 ohms, 534, okay. Get decent connection, come on. Zero ohms, 2.8 millifarad. 0.3 ohms, 2.8 millifarad. So this one's slightly different to the other one. So the fact it's showing something's interesting. Let's go to dissipation on this one. Again, get a decent connection. .1, yeah, that's probably right. Compared to the other one. 0.19, yeah, that's probably nothing. Okay. It's not looking too bad. It's nothing obviously that bad. But there are some slightly elevated ones in there, obviously. This one here I'm slightly suspicious of. for instance. Unfortunately I can't read the values of most of these things. I tend to recap it, but we'll power it up first and we'll see what we get from that. I might even shut the scope on it actually. We'll get a pretty of a probe around. The capacitors, at least on this meter here, aren't really showing it much in the way of ripple coming out. They're all looking okay. There's no real detection of any AC coming through. So we've got some test points down here. So we've got a minus 5 volt rail there, which is indeed coming out as minus 5. I'm not sure if it's in spec or not. I might have to just check that and confirm that level. I think it might be slightly off, because these are like reference supplies. There's also a minus 14 volt there as well. Same deal, I might have to check that one. These two have adjustments. So adjustment here and adjustment there. So I might have to just look at that. I have to say go and read the manual and check that up. And if I reference off the ground here, which is like the main chassis ground, I'm going to these connectors. Some of these have voltages on them as well. So it does have like an isolated floating system as well, so it's a bit tricky to make sure I'm measuring the right places. There's a minus 15 there, plus 15, and plus 5. Both of these pins, basically, both of them plus 5. So the main rails appear to be there. There was an 8 over here as well. Where was that one? It was over here, was it? Yeah, there's an 8 volt rail just there. But there's probably some more. I'll have to look at it. And if I stand on this back, can I see more from that? Some of these are in parallel, some of them are not. I think there's a couple of extra pins there which are a little bit different. Let's just go in here. And this one's different. That's a minus 5 volt rail there. Okay. Yep, so that's about it, I think. The power supply at least seems to be working similarly in spec, at least from what I can see from that. I might hook up my scope on a differential probe or something like that and just go through it just to be absolutely sure I'm floating properly, because I know one of these supplies are floating. This supply here is floating at least. This one's ground reference, which is okay. So I could check those ones with the scope because I know they're ground reference. In fact, I think I'll do that. So I've got my scope hooked up, I've got AC coupling set up, no bandwidth limit. So we'll see what we're getting. Now, if I probe on the minus 5 volt rail, which is at test point, getting very little there. Although my scope's saying there's 280 volts, 280 millivolts peak to peak. Yeah, there's not really that on the waveform. It's just radiated noise in my area here. If I do the floating ground, which is at a minus 14 volt rail, we can see they've got ripple on there, which is interesting. It's 1.1 volts it's measuring there. I'd believe that, potentially. And then I've got the minus 14 volt rail itself is also like that. So that floating volt rail, that floating rail there, I might have to look into that in a bit more detail. And that's 1 kilohertz as well, or so. Three kilohertz, maybe. Right, let's go and look at the other rails. See what we find. Well, these are all looking fine so far. Yeah. They're looking alright. Let's go onto this connector here. Check everything. And what's that one there? So that's about 900 millivolts peak to peak. Let's keep on that one. Which one's that? It's a 4th pin in. Yeah. Okay, let's keep looking. There might be one of the floating rails. Okay, all the others look alright. There's that one rail which is rippling. So let's just trace that one back. Three, four. That's that one there, that pin there, okay. There's also this other connector which I didn't look at yet. Oh. I think this is the floating rails. Yes, 1.4 there, 1.14. This is that floating supply. Okay. So there's one rail over here which looks interesting. Let's try and trace that. Interestingly, pin 4 doesn't appear to go anywhere. It goes to an empty pad. So it might just be induced noise. Well, that's double-sided board, I can't see though. So I'll have to look at the circuit diagrams for that and trace that one out. But the other rails look alright. So it's just that floating supply I think is really the issue, and that pin 4 on this connector, which I'm not sure of yet, to figure that out. Okay, so after looking at the circuit diagram for this power supply, I'm pretty sure that this floating rail, where I was getting a 1.1 volt ripple on the reference and on the 14 volt output itself, I'm pretty sure that's wrong. Now these two big caps here, of course, the plus and minus sections of that floating section. So one's plus 14 volt, one's minus 14 volt. And with also the reference, ground reference there, or the floating ground reference between those two caps. So I think I shouldn't be getting that much ripple there. So I'm going to change both of those caps. The 1000 microfarad caps, I've got some 1000 axials here. They're somewhat smaller, but these are 40 volt caps, so they should be enough. I've also got these other ones which are 35 volt as well. So it depends on what voltage these are. I think it's probably only about 20 volt rail or something like that on actual going into it. So I'm going to replace those two caps there and we'll see how we go from there. Alright, so positive downwards this way because you've got the depression on here on the casing, which always designates the positive end. It's also, I mean, maybe see on that one, it's got a positive just there too. And the pads, you've got a round pad this end, square pad this end. Square pads usually mean the positive. Not always, but usually. Let's see if we can get this out. Go on, don't be stubborn, it's been bent over, of course. I'll try and flatten it back out. Right. Okay. Now, iron might be a bit hot for this board actually. Oh, it's 270, 370 I'm on. Turn it down a little bit, let's go down to 350. Got quite a big tip on here right now too, so it doesn't need as much heat. Go. So what we got, 1000 microfarad, 35 volt. So that's fine. That's what I'll put back in because that's exactly what I've got sitting in this drawer here. Okay. Let's get the other one out as well. Is that the right cap? Or is it over here? Is that one there? Right. Let's double check. Yeah, that's the same as well, as expected. Now I should probably clear these holes out. What I might do is get my desoldering gun warming up. We'll suck those holes out with that. And so I'll use these two ones here. I'll use these caps. These are the same specs. Well, basically the same spec, 35 volt, 1000 microfarad. And then we'll retest the ripple on that rail, we'll see if it looks any better afterwards. But you can see there's a bit of a difference in size between modern technology and old technology. This power supply, the transformer has got a Marconi at 1978. So it's a later version. I think these came out in like 74, I think it was 74, 75. These things came out in the manual. But it's got September 78 on it, just on there. Well, it might be 9th week 78, it could be either one. Could be 9th week 78. Is there any other date codes I can see in here? Underneath the dust. CMC 145 8. Yep. 1977. Can't see what that is. 1977 as well. So yeah. But it says 78, so it's 1978 unit anyway. Okay. Mind your ears, this thing's loud. I've changed a bit on it. I got sick of the bit being too big, so I've got a smaller bit on there now. Let's see if it helps. Can't quite get to that one, I think. At least not from this side. It's over on this side. Yep, cool. Done. So this type, if you don't know this, try and move to where it's in focus, which is a bit right further over here. So you can see it's got like an arrow pointing for negative, right? So that means that end is negative, but also has the same as the other type, where this end's got a depression in it. Right, so there's a dent in here, again that signifies the positive end. And say negatives pointing like an arrow, means that's the negative that way. In case you don't know how to read these things. Now whenever I put these in, I always put them so you can read the values and the polarity if possible. Okay, so this has got to go in that way up. So I'm going to shove them in like this. That way you can read the polarity and the values at the same time if it's in circuit. It just makes it easier for the next person working on it. It might be me, it might be somebody else. Who knows? It'll probably be me. But I tend to get rid of stuff. Although I do have some stuff for sale right now. I've put it on the EV Blog forum too. Put it up on there in the for sale section. Got a few things which I repaired which I'm trying to flick off because I don't actually require them anymore. Or maybe at all. Right, let's get solder on. Now, being test gear, I'm going to use silver solder. I use good solder on this stuff now. Now I've got the decent solder, I use it on anything which requires a high level of quality. Although it's only power supply, it shouldn't really matter, I should be using the other stuff, but I've got the good stuff, so I'm going to use it. The other side, make sure it's flowed through. Yep, it's all good. Let's cut these off. I'll just put put my cutters away yesterday. Get them back out again. I might just leave them out. Let's try and clean the flux off. Just because, you know, that's what we should do. That'll do. Here's only power supply after all, it's not critical. Now, let's do this test again, shall we? Let's see what we get. We're still getting 1.1 volts ripple. So that hasn't changed anything. So, okay, well, I guess that's fine then. Because that's obviously just the way that section works. Oh well, at least we've got 2 caps replaced. And I did test okay, so I was a bit surprised I needed to change them. But oh, in the pile. Well, seeing as I'm in here, I've got my irons warmed up, you know, my desoldering gun. I'm going to take these 2 caps out, because this front one here I was suspicious of the value because it was different to this one. So I was a bit suspecting that one's a bit dodgy. So I'm just going to replace that pair as well. You know, why not? I'm already basically set up for it. I've got some caps I can chuck in. These are 22 microfarad, 25 volt caps. I've got some 22 microfarad, 35 volt caps sitting here. So I was going to swap those out, and then, you know, leave it there. Maybe I'll do that one too, just so I've got this whole section done. What is that one? That's a 10 volt. I think it says 220 microfarad. Yeah, 220 microfarad, 10 volt. Well, I've got 220s, so I might chop that one out as well. Actually, I might do that one too. What's this one? 220 microfarad, 25 volt. It's about, so it's still smaller. So we'll swap those 3 out. Then we've done that whole floating section, apart from that tantalum was sitting there. And then at least then I'm confident that side's be alright. Yeah. I'm not going to do the whole thing. I think it, you know, ripple wise it seemed alright apart from this floating section. That's the only bit I'm really worried about. So we'll change those out. So negatives are all facing to the right. I have to put fish solder on, let's see if we go. Slipped off. Next one. Just trying to decide if the film's bulging or not. Where the bottom's coming out. I think it's okay. Just looks like it's slightly proud. Might be fine. Okay, let's drop these new ones in. Check the polarity. Always check the polarity. Now of course this case style is slightly different, they're not going to fit perfectly. It's slightly smaller. But it doesn't really matter much, really. Pushing down as far as I'll go. That one here fits fine because that's the right size. Okay. I'll do one side, make sure I'll put it down as far as I can, and do the other side. Yep. Yep. Shall we check it again after this? What do you reckon? See if anything's changed? Might be an idea, eh? It's not quite flowed through. Get some more. Okay. I doubt anything's changed, but you never know. Let's do it anyway. Out of curiosity. Right, let's give it another go. What do we get this time? Yeah, it's the same, no difference. So I think it's just the way that section is. That section just ripples along itself. It's just floating the whole thing, so I don't think there's a problem. I think that's alright. Okay. Well, what I need to do now is look at the other side of the unit again and go from there. Yeah. Right, solder this earth wire here back on again. Rebuild the unit. We're worried about leaving on these things because they might snap off. Being old plastics, they go brittle. So this connector here, which goes on that one. Make sure we get it right around. Try and show what I'm doing as well. Turn it around. So this one goes in there. Put a T on it so I know which way around it goes. T for top, which is the way it was at the time when I took it off. Then you've got this connector here, you've got a top on that side, so that goes in there, like that. It's a nice tight fit. These are all gold plated connectors, all gold plated pins, that's quite nice. Since we close up it so I can get this one on. Same deal on that one there, the markings match up. Try and get the thing to bed right down. There we go. Very tight connectors, which is good actually, because you want them to be tight, you don't want them to be loose. And that one there, I had that marked as well, the line, and that's fine. That's in. Okay. So we'll slot this back together.